wondered why the sound of an ambulance changes as it rushes by? Or why the car next to you blurring it sounds like it's singing a high pitch as it zooms past? Does this thought ever pop in your mind that no matter how fast a car or ambulance is driving, it's still making the same siren sound, right? So why does that sound seem to change pitch as it approaches or drives away? Is it just your ears playing games with you? It's some sort of sorcery, or is there some science's magic going on here? Let's try and find out.
This cool effect is named after Christian Doppler, an Australian scientist who noticed something strange about how sound and light behaves when moving. Imagine this as if it's currently 1842, and Doppler probably wearing a giant mustache, thinking, I wonder if sound waves act differently when things are moving fast. And big spoiler, they do.
To explain it simply, here's the basic idea of a Doppler effect. When a sound or light source moves toward you, the waves get squished together, making the pitch sound higher. And when the source moves away, the waves stretch out and the pitch lowers. Here's where the thing starts to get fun. So, we have a ball with a buzzer located inside. One person twirls the ball around on a string or tosses it back and forth with a partner. As the ball comes towards you, you will hear the pitch of the buzzer get higher, and when it moves away, the pitch drops.
Want to see a cool trick? Grab a tuning fork, strike it to make a sound, and then hang it up so it can swing back and forth like a tiny pendulum. As the tuning fork swings toward you, the pitch will rise. As it swings away, the pitch drops. We'll watch a video of an ambulance driving by with its siren on. When the ambulance is heading toward the camera, the pitch of the siren will be higher, like it's yelling, "Hey, I'm here!" But as it moves away, the pitch drops, almost like it's saying, "Bye, have a good day." This is the Doppler effect in action, folks. Science is cool and interesting. Websites like PHET have cool simulations where you can mess around with the Doppler effect in real time. Not just with sound, but also with light. You can watch how the wavelength of light changes as stars or galaxies zooms toward or away from Earth. It's like Star Wars, but with real science.
Do you remember that ambulance example? Here's a quick breakdown. When the ambulance approaches, the sound waves in front of it get squished together, which makes the pitch rise. You hear the sound as it zooms closer to you and the ambulance moves away. The sound waves stretch out behind it, which makes the pitch lower. You hear the sound as it drives off into the far distance. You might wonder why this happens. Let me answer that question for you. This occurs because the ambulance is changing the way its sound waves are moving towards and away from you. It's like someone pulling on a rubber band. When you stretch it, it gets thinner. Sound waves get thinner or squished together, depending on how the source is moving. So even though the ambulance is always making the same noise, the way you hear it changes based on the Doppler effect. Pretty wild and interesting, right?
Why is this concept important? The Doppler effect is just a trick to make ambulances sound like they're on a musical roller coaster. It's actually super important in many areas of science and technology. Here's why you should care about the Doppler effect. Doppler effect is important in astronomy. Astronomers use it to determine whether the stars, galaxies, or even entire clusters are moving toward or away from Earth. These astronomers analyze the light that are emitted by these celestial objects. They can detect shifts in the light's wavelength. It's like astronomers have their own form of cosmic radar, helping them track the motion of distant objects in the universe and even measure their velocity across vast distances.
The Doppler effect is also important in the medical field, where doctors use it in ultrasound machines to monitor blood flow and detect any abnormalities. By measuring how sound waves bounce back as they travel through the blood vessels, they can determine how fast your blood is flowing and assess the health of your circulatory system. This technology helps diagnose conditions like blockages or blood clots, providing a non-invasive way to see what is happening inside of your body. Weather forecaster also uses the Doppler effect in their everyday line of the world. Have you ever heard of a Doppler radar? It is a very essential tool that meteorologists uses to track storms and predict their movements. By sending out radar waves and measuring how they bounce back after hitting moving storm clouds, they can detect changes in the speed and direction of the storm. If the radar waves are compressed, the storm is approaching. If they are stretched out, the storm is moving away. This ability to see the movement of storm in real life is crucial for accurate forecasting.
Just like how it was explained earlier, the Doppler effect helps to explain why the pitch of ambulance sirens seems to change as it moves toward you and then away. As the ambulance approaches toward you, the sound waves get compressed, which cause the pitch to rise, and then as it moves away, the waves stretch out, which then lowers the pitch. This phenomenon isn't just a quirky thing that happens in everyday life. It's a real-world demonstration of how motion affects sound waves. Has it ever crossed your mind how scientists study earthquakes? With the help of Doppler effect, seismologists can analyze the ways seismic waves move through the Earth's crust. Through observing how these waves change in frequency and speed as they travel, they can gather valuable information about the Earth's internal structure. It's similar to listening to Earth hum a song, but instead of melody and rhythm, you're picking up the Earth's vibrations. With more shake and fewer dance moves, a powerful but subtle way of hearing the planet's movements from deep beneath the Earth's surface.
Fun fact! Did you know that some animals, like bats and dolphins, use the Doppler effect in a fascinating way to track their prey? They emit a high-frequency sound waves, which then bounces off nearby objects or animals, and by analyzing how the sound waves changes when they return. These animals can figure out not only how far away their prey is, but also how fast it's moving and in what direction. This ability to detect motion with such precision helps them hunt in complete darkness or murky waters. These animals rely on echolocation for navigation and food. It's like they have their own built-in Doppler radar, allowing them to see the world through sound waves. That's pretty impressive, right? So next time you hear an ambulance zipping by, don't just think, "Wow, that's loud!" Think, "Wow, that's science!" The Doppler effect isn't just a cool party trick with sound waves. It's a concept that helps us understand everything from the stars in the sky to the blood flowing in our veins. The next time you hear a passing car or a siren, you'll know it's not just noise, it's science just doing its thing.